Hi guys, I welcome you all to my channel CSNet Lectures. So in this session, we are going to discuss about another algorithm of queue data structure. It is nothing but Dequeue. That is how to delete an element from the queue data structures. So in the last classes, we discussed about how to insert the element using an algorithm. So here we are going to discuss about deletion algorithm of queue data structures. So in the same way, we have initialized different variables for using it in my algorithm. So n is equal to 5, int q of, so maximum size of the element is n, q is an array data structure, so see the same variables I have used it. Okay, so suppose if we cannot understand these variables, you can see it in my previous video. Then f is equal to -1, r is equal to -1. So all these variables we are using it in the similar way, right? So now int and item. So this is for deleting the element from the queue. So now in the last class I have used a for loop, right? So in this session we are going to use a while loop, right? So see here I have incremented the value of I. So initially let this I value be 0. int I is equal to 0. Okay, this I have not mentioned it, so I have added it over here. So now shall we go for discussion, right? So here I have used similarly 3 if conditions. Okay, so now if you see the first if block is going to check whether the conditions whether the queue is empty. Okay, suppose if the queue is empty, that is if there is no element present in the queue, can we delete the element? No, we cannot able to remove any element. So for that we have used this loop execution, condition execution. So next is this one. As there is no space, friends, I have written it in the same line. Okay, so please excuse me for that. So now item is equal to q of f is equal to -1 and r is equal to -1. So this condition is used for checking if there is only one element present in the queue. If it is only one element, what we are going to do? That we are going to execute it here, right? So next one, if there are as much as element present in the queue, how we are going to delete it? For that we have used this condition. So now shall we go for discussion, right? So before starting, let me draw a queue data structure. 1, 2, 3, 4. Okay, so now this is a queue. Now I am going to start checking the conditions. So now initially I is equal to 0, right? So now use that I value in the while loop. So initially what is I value? So I value is 0. What is n value? N value is 5. Is this condition true? Yes, this condition is true. So now it is going to execute all these looping condition statements. So what is the first value? So f is equal to -1. So what is the meaning? So the meaning, if you see or if you view this queue data structure, there are no element present in the queue. So if there is no element present in the queue, is there any use of using the pointers? No, we will be taking the pointers away from the data structure. So now what will be the value of front end here? So front end here pointer value is going to be -1. So this we are going to see. Suppose if these two values are null, we cannot able to delete the operation, isn't it? So if it is true, it will print that queue is underflow. What is the meaning of underflow? So underflow meaning is empty. So we cannot further delete any elements. So it will check and it will come out. So now if you see, this condition is true, isn't it? See, initially for example f is equal to -1 and r is equal to -1. So this condition is true. So it will print as underflow. It is going to come out of the loop. So break. So what is the use of this break statement? So break statement is going to come out of this execution of the loop data structure and it is going to stop the operation. So now for example, if there is only one element present in the queue, for example only one element is present in the queue data structure, all these previous elements are being deleted. In this case, what it will do? So front will be pointing here, isn't it? Rear also will be pointing here. Okay, so now what is the value? For example, 0, 1, 2, 3 and 4. So front is also 4 and rear is also 4. Okay, in this case what will happen? So for that we have used this else if condition. If front is equal to rear. Okay, so now what is the value? 4. What is our value? So our value is also 4. So what I will do? I will remove this element also out of the queue data structure, and I am going to remove this pointer back to, sorry, I am going to remove and reassign this pointer back to -1. This I am going to do now. See, so for removing this item, I am using this assignment statement as item is equal to q of f. So for example, q of 4, isn't it? So what is q of 4 value? Q of 4 value is now for an instant 10. So now this 10 is going to get removed and it will be assigned to item. So item is equal to 10. So now in this question also there is no element. So what I want to do? I want to reassign this pointer value to -1 and -1. So for that only I have written these statements. Okay, so now take away these pointers and once again you assign this value. Friends, are you all clear? So this block is used for printing if there is no element present in the queue. So this block is used for deleting only one element that is being present in the queue. So now we will see this statement. For example, now if queue is having a certain number of elements. So for example, it will be 11, 12, 15, 18, 20. So these are all elements that is being present in the queue. So now, for example, now where will be the front pointer? So the front pointer will be here, isn't it? So this is the first element. So this is your R. So R is your last element. So now, which I want to remove? The front element has to be removed. So for that I am using this statement. So if both the conditions are false, okay, only this part is going to get executed, isn't it? So let me explain you again. See now, for example, this condition is true. Now let me go inside the condition statement. If f is equal to -1. So now tell me this condition is true or false here. So now f is equal to 0 and r is equal to 4. Isn't it? So is this condition true? No, false. So it is going to come out. Isn't it? So now it will go for the else if block. So now if you check for the else if block, f value is 0. Now r value is 4. Is this condition true? So this is not true. So this will not execute. So this is going to come out. So now it will check for this else block. Check means I am telling that this is going to execute if both the conditions are false. So now what is going to do? Item is equal to q of f. So what is this f value? So f value is 0. So I am going to remove the element which is pointed to by the front pointer. So this is 11. So 11 will be removed and it will be assigned here. So now you see, is there any necessity for this f pointer pointing to this empty space? Tell me, is there any need? No. So what I should do? So I must have to increment this front pointer and make it to point to the next first element. So the next first element is 12 here, isn't it? So for that I have used this increment operation for the front pointer. So now front pointer will be pointing. Friends, are you clear? So like this only we are going to delete each and every element present in the queue. Okay, shall we delete all these elements? So now if you see, now front element is 1, isn't it? So now rear element is as usual 4. Okay, now let me take this elements and we can execute this entire loop structure from the beginning. Okay, so now initially let I value be 0. Okay, so 0 is less than 5. So this condition is true. So it is going to check all the conditions. Now it will come for this if condition. So f is equal to -1. So this condition is false, so it will not execute. So again you go here. So now if you see, f is equal to 1, isn't it? So this condition is also false. So 1 is not equal to 4, isn't it? So this is also false. So only this block will be executed. So now f value is 1. F value is 1. So remove that element present in the front pointer. So if you remove this, 12 will be deleted. So now what will be the item value? So item value is going to be 12. So now what I should do, the next front element is 15. So I should have to make the pointer to move here. So move this front is equal to front plus 1. Okay, so now what will be the front pointer value? So now the front pointer value is going to be 2, isn't it? So now 2. Once again, we are going to start executing the loop. So what is I value now? So I value is 1. I value is 1. So once again this condition is true. It is going to come inside these block of statements. So once again if you check for f, so f is not equal to minus 1. So f is once again not equal to 4. Isn't it? So both these conditions are false. So again it will execute this statement. Okay. So item is equal to q of f. So what is f value? F value is q of 2. So it is going to remove the element present in q of 2, which is nothing but 15. So 15 is removed, and once again we are incrementing the front pointer. Friends, are you all clear? F. Now f value will be 3. Okay, so once again what is this I value? So now I value will be 2. See, I am incrementing I value also here in the bottom, isn't it? So now I value is 2. So once again this condition is true. Once again we are going to execute the same block. Again if you test the value of f, this will also become false. This will also become false. So this else block will be executed. Right, because f is 3. So 3 is not equal to 4. So none other go, only this will be executed. So remove the element present in the third position, q of f. So this also will be removed. So once again I am incrementing the front pointer. So the front is pointing to this location. Right. So now what is this front value? So front value is going to be 4. Right. So now once again come out of the loop. So once again I value is going to get incremented. So I value will be 3. So I value will be 3. So again we are going to execute this same statement. So now if you check, is this condition true? So f value is 4 and here the f value is minus 1. So this condition is false. Okay, so this will not execute. So now we come here for this else block, else if block. So now what is f value? So f value is 4. So now if you see, f value is also 4 and our value is also 4, because this is the last element present in the Q data structure, which I am going to remove it now. So as this condition is true, so this statement is going to get executed now. So item is equal to Q of 4. So 4 element will be removed. So remove this element. Okay, so I am going to store it. What was that element? For example, 10, I think so, 10. Okay, so I am removing this element and I am storing it here. Is there any necessity for the pointer to point again and again in this location because the cube is empty? No, not necessary. So once again I am going to take away the pointer from the Q data structure. So remove this pointer and make it to point here. Okay friends, so like this only the deletion algorithm is going to get executed. Okay, if you see, we have removed all the elements based on conditions that is being written over here. Okay friends, I think so you will be clear about how the deletion operation is being performed in Q data structure. Okay friends, and thank you for watching. Suppose if you have any doubt, you can give me in the comment section. I will explain it to you clearly. Okay friends, bye and thank you.